good evening. We are welcome to another series of Mathematics Made Easy by Nnodi. And today we'll be solving some questions on physics. We'll start with the first question. It said, which of the following units is equivalent to joules per second? Which of the following units is equivalent to joules per second? A. Farad. B. Hertz. C. Newton. D. Pascal. E. Watts. Okay, so you see that Farad is the SI unit of capacitance. Farad is the SI unit of capacitance. Solution: capacitance C is equal to charge over the potential difference, and the SI unit of capacitance is farad. It's measured in farad. Now, concerning hertz, the SI unit of frequency is hertz. Frequency is equal to the number of oscillation over time taken, or you can say the number of cycles per time. You can say frequency equal to number of cycles per time. Now the SI unit of frequency, is hertz, or per second. That is s raised to power minus 1. Now another one we'll look at is Newton. Newton is the SI unit of force. Force F is equals to mass times acceleration. So F is equals to MA. And the SI unit of force is Newton. The SI unit of force is Newton, that is N. It is also measured in kilograms meters per second square. Okay, that is the SI unit. Kilograms meters per second square. Post it first. Alright, now the next one you will look at is Pascal. Now pressure is defined as force per unit area. Pressure is force per unit area, and the SI unit of pressure is Pascal, or Newton per meter square, either measured in Pascal or Newton per meter square. Why? You see that force has a unit Newton and the SI unit of area is meter square. So this is Newton per meter square, or it is called Pascal. Now we come to this other last one, which is watts. Watt is the SI unit of power. The SI unit of power, specifically electrical power, is measured in watts. Electrical power is measured in watts. So you see that power is equals to work done over time, and then this work done has a unit joules. So this is it. The SI unit of work done is joules, and the SI unit of time is seconds. The SI unit of work done is joules, and the SI unit of time is seconds. So this is joules per seconds, or joules s raised to power minus 1. That is the SI unit of power. So it means that therefore power has an SI unit, joules per second, or watts. Joules per second or watts. So the question is, which of the following units is equivalent to joules per second? The answer is watts. Watts. That is it. This is the SI unit of power, watts. Alright, we'll look at the next question. We'll look at the next question. Look at the next question. Like I said earlier, this is Mathematics Made Easy by Prosper Nnodi. So let's observe as we solve more problems on physics today. The second question is, say the speedboat travels at an average speed of 20 meters per second. Calculate the distance it will cover in 25 minutes. Calculate the distance it will cover in 25 minutes. A, we have 75 meters. B, we have 500 meters. C, we have 15,000 meters. D, we have 30,000 meters, and E, we have 45,000 meters. Solution. Okay, let's look at this question. See, the speedboat travels at an average speed of 20 meters per second. It travels at an average speed of 20 meters per second. Okay, let's solve that. The first thing we'll look at is we'll look at the speed. The speed was given to us. The speed was given to us. Speed V was given to us as 20 meters per second. 20 meters per second was the speed given. And then the next thing you look at is the time. The time there is 25 minutes. the time t is 25 minutes. Of course, you have to convert these minutes to seconds, which is the SI unit of time. Now, converting minutes to seconds, we know that 60 seconds make 1 minute. Now, this will be equals to 25 minutes times 60 seconds divided by 1 minute. So minute we cancel minute, and 25 times 60 gives us 25 times 60 will give us 1500 seconds. 25 times 60 gives us 1500 seconds. That is, using your calculator, you will obtain 1500 seconds. Now, the next thing you look at is the formula for speed. Speed is the ratio of distance to time, or you can say it is distance per unit time. Speed is distance. Speed is distance per time. Speed equals to distance per time. That is, V equal to S over T. And making S the subject of formula, you have that this is V times T. This is V times T. Okay? So now, distance will be equals to, the value of speed here is what? 20 meters per second. Times the time is what? 1500 seconds. Okay? So what then will be the value of distance S? What then will be the value of the distance S? We have to work that out. To work it out, this is 20 meters per second. That is m over s times 1500 seconds. This we cancel this. Of course, distance is measured in meters. 20 times 1500, 2 times 15 is 30. So 0, 0, 0. We have 30,000 meters. The distance is 30,000 meters, which is option D. Option D is the answer. 30,000 meters. We'll look at the next question. The next question here deals with friction. Question number 3 deals with friction. It said, in which of the following process is friction not an advantage? In which of the following process is friction not an advantage? Let's look at this. In which of the following process is friction not an advantage? As usual, we have about 5 options and only one of them is correct. The first option is this. First option is this. Option A, we have applying the brakes. Applying the brakes of a moving car. Option B, lifting a load with a pulley. Option C, motion of a belt over a wheel in a machine. Option D, sharpening a knife. And finally, you have walking. So the question is this. He said, in which of the following process is friction not an advantage? In which of the following process is friction not an advantage? First, they talked about applying the brakes of a moving car. Now we see that friction is a force that opposes relative motion, and it occurs between two bodies or two surfaces in contact. If you look at a moving vehicle, the brakes of the moving vehicle actually ensures that the car comes to a stop, perhaps when it encounters an obstacle. So that is an application of friction. Once you step on the brake, the car stops. This is one of the merits, the advantages of friction. Then look at B, lifting a load with a pulley. This is not actually a merit. This is not an advantage. But if you look at C, they say the motion of a belt over a wheel in a machine. Yes, in most of these industries, you see these belts and chain drives, they function on the principle of friction. Then sharpening a knife. In a grindstone, you apply the principle of friction when sharpening a knife. Yes, when you rotate that particular wheel, you put the blunt edge of the knife and it sharpens it with the aid of friction. And without friction, walking will not be made possible. You just slip on the ground and fall. But it is via friction we humans can walk. So this is an advantage, this is an advantage, this is an advantage, this is an advantage, but B is not an advantage. So the correct answer is B. He said, in which of the following process is friction not an advantage? Not an advantage. This is not an advantage of friction. We'll look at the next question. Question number 4. Question number 4. Question number 4. Question number 4.